Good evening. Today we'll be discussing topic called safety equipment. For the learning outcomes, we will be able to discuss the correct methods for handling, storage, and disposal of hazardous chemicals used in the lab safely. And we'll also be able to explain the safety procedures related to hazardous chemicals in the lab. This will be our table of contents, which is the introduction, personal protective equipment or PPE, lab safety equipment, fire safety equipment, and in the end, we'll be able to reach the summary of this topic. For the introduction, the availability and use of safety equipment is essential to the practice of safe science. They should be present in well-marked, highly visible, and easily accessible locations in or near all laboratories that use hazardous chemicals. From this graph, we can already tell what are the PPE required. So we can see there is glove, safety shoes, ear cover, safety helmet, respirator, and also safety goggles. So these are the essential of laboratory safety equipment. We'll be discussing about personal protective equipment, or in short, PPE. So what is PPE? It is a gear, a type of gear or clothing used to protect the wearer from specific hazards and also hazardous materials. It is also known as final protection system to be used when administrative and engineering controls do not reduce risk to an acceptable level. So we do not have any option other than wearing PPE. If it is the work setting, we would be facing some unavoidable circumstances or hazardous that is we have no choice than to be wearing PPE. PPE does not reduce or eliminate the hazard, but only protects the wearer. These are the basic PPE that we always see in the lab and we always practice. So this is the safety goggles, lab coats, and also the glove. So for the safety in chemical lab, the use of chemicals poses high exposure and risk based on the hazard quantities and also type of operations. Predominant area-based hazards are eye and skin exposure to chemicals. In simpler words, it would be that any work setting involving safety and health concern for chemicals that will come in contact with eye and skin. These are the main risks of safety and health, which is the eye and skin exposure to the chemicals in work setting, such as if the chemical spill is to occur, it will cause itchiness on the eye or maybe burning, that it can cause the eye to be blind, or if it's the skin exposure, if it is we come in contact with the chemicals, there will be maybe irritation, rashes, or burning. So minimum PPE requirements to work in a chemical lab, including lab coat, long pants, fully enclosed shoes, safety glasses, and gloves. For the long pants, since a lab coat is typically knee-length design, so it does not completely protect our lower part of the body. So we have to wear the long pants to completely cover our whole body from coming in contact with all the hazardous chemicals. It also is important to be aware of the hazardous materials will work or which you may come in contact with and adjust your PPE accordingly. PPE also includes eye protection, gloves, maximum skin coverage, and closed-toe shoes. One is about adjusting our PPE accordingly. There will be in some cases we have to wear some extra protections such as aprons, respirators, flash shields, earplugs, and specialized gloves. That will be discussed after this. We'll be discussing lab coats first. it is not just worn to make a fashion statement, although it looks like so. It is an essential role in proper lab safety, which is a common thing and also basic thing that everyone should know who is working in lab setting. Lab coats is the most essential. So should a chemical spill occur, these long white coats help preventing your skin from dangerous liquids and particles. It is typically designed to be long sleeve, white in color, knee-length coat. It is usually made of cotton and polyester or other naturally absorbent material, but typically it is cotton. And then lab coat is also essential by helping to prevent liquids or other dangerous chemicals or particles from contacting clothing or skin. Um, if a spill occurs, we should be remove the lab coat. Doing so will prevent chemicals from soaking through the skin. And for eye protection, lab coat should always be buttoned close because there are some people that only wear the lab coat over their internal clothing but does not button it. This is should be a wrong SOP to follow because we should be protecting our whole body from chemical spill, including including the front part. This is a close-up of the design. It is long sleeve. And we should not wear outside of the lab if it's possible to avoid contamination. So if we're already in the lab and we are going out for toilet break or pantry, we have to take it off for a while. We have to take it off for a while, and then wear it back when we are coming back into the lab. And it can protect the user from chemical splash as well. Next, we'll be discussing on safety goggles. Eyes are one of the most sensitive parts and it's vulnerable to hazardous chemicals and materials. So hence, proper eye protection is very important. It is the ideal form of protection because they shield both sides of your face to prevent materials from entering your eyes. By choosing the right type of safety goggles, is very important. Some goggles are designed to protect against physical impact, and there's also the type of chemical splash goggles that is ideal for those who work with chemicals. In addition, there's also goggle type that can protect us from laser or UV light hazards. Due to the different types of goggle, we can select the most suitable eye and face protection that follows these elements. First is the ability to protect against specific workplace hazard. It should fit properly and be reasonably comfortable to wear. It should provide unrestricted vision and movement, should be durable and cleanable, and should allow unrestricted functioning of any other required PPE. Not just the front frame, but it is also designed to have frames surrounding the area of the eye, so it can cover um, above, left and right, and also from below. This is if we wear the goggles, it will provide like a snug fit on our eye, so it can prevent any other particulates or chemicals to come in between and come in contact with your eyes. So safety glasses must meet the standard for impact resistance and have side shields for splash protection. Side shields is, as mentioned before, so safety glasses or goggles must be worn over prescription glasses. Safety glasses worn over prescription glasses must be of the type intended for this purpose. And also, there's also chemical goggles. One of the type of the goggles, it may be required for certain process, which safety glasses are deemed inadequate for the type of activity or experiment that we conduct in the lab. So we have to opt for chemical goggles rather than safety glasses. And we cannot wear contact lenses in the lab because it is dangerous if there is a chemical splash. Safety glasses and goggles provide protection against potential impact, whilst goggles and Face shields provide the best protection against chemical splashback. There's also head shields. In addition to safety glasses or goggles, it can protect the person from any potential explosion. It should also be noted that regular safety glasses cannot block UV rays. It should be noted that regular safety glasses cannot block UV rays, and lasers and special safety glasses must be worn while working with UV rays and laser. So this explains that depending on the setting that we're working with, or the experiment that we are working with, that we should carefully select the type of goggles that is suitable to be worn while doing the deed. Next, we will be discussing face protection. It has to be worn over safety glasses and required for face protection. It has to facial. It has to be worn over safety glasses instead of just safety glasses or goggles. So the condition or processes that involve wearing face shields are including high pressure reactors, which is more than 30 psi, or pneumatic lines, which is also more than 30 psi, high pressure airlines, machining operations, and some cryogenic or the one that is holding the liquid helium or liquid nitrogen. Procedures require the use of face shields over safety glasses. Next, we will be discussing on respiratory protection. The device is called as a respirator. It is designed to protect the wearer from inhalation or harmful substances. When chosen correctly and used properly, respirators can protect the wearer from harmful gases, mist, vapors, fumes, and fine particulates. Respirators are a last resort when it comes to protecting people in the workplace. There are two general classification of respirators according to the mode of operation. The first one is atmosphere supplying respirators, and the second one is air purifying respirators. So we can see from the photos here, this is the atmosphere supplying respirators, and this is the air purifying respirators. Typically, atmosphere supplying respirators is connected to tank of oxygen, where the tank will function to supply oxygen inside the respirator. And while the air purifying respirator is designed to filter out any foreign materials from entering our respiratory system. So, for example, N95s are airborne particulates respiratory protection program, which includes respiratory hazard evaluation and medical clearance. There are many different types of respirator, and they also have color coding for the cartridges. So this is the code 6001. For example, 6001 for organic vapor protects us. If we're handling organic vapor, we have to use the cartridges of black color. Next, 6002 as the code. If we're handling acid gases, we should wear cartridges of the white color. If we're handling organic vapor or acid gases, we have to wear yellow color. If we're handling ammonia and methylamine, we have to wear the green color. If we're dealing with formaldehyde or organic vapor, we have to wear a combination of olive and black color of cartridge. If we're handling multi-gas or vapor, we have to use olive cartridge. And if we are dealing with mercury vapor or chlorine gas, we have to use orange. So the company 3M produce different types of respirators. So for example, this is the particulate filters. It filters only aerosols. For example, dust, mist, fumes, smoke, mold, bacteria, etc. Some filters also have nasal stable gas and vapor capabilities. Next is gas and vapor cartridges. It filters only gases and vapors. There are different kinds of cartridges for different kinds of gases and vapors. Next will be the combination cartridge or filters. It filters particles, gases, and vapors. Different combination, particulate or cartridge filters are used depending on the gas or vapor present in the air. So these are the categories of cartridges used in respirator. Next, we'll be discussing hand protection. So the type under hand protection is of course protective glove. So when working in our lab, our hands are at the most risk other than our eyes due to the contact with hazardous chemicals. So by wearing suitable protective glove, we can reduce our risk of injury. The main types of disposable gloves are made of latex or nitrile. These are the common types of gloves. Gloves with stronger protection also include chemical and heat-resistant gloves, which we'll discuss the types after. So before choosing which type of glove to wear, we have to carefully rate the appropriate STS to determine the level of protection that you'll be needing, and to determine what kind of glove that is most suitable to handle that kind of chemical. Okay, so chemically resistant lab gloves come in a variety of materials such as natural rubber or latex, butyl rubber, polychloroprene, nitrile, polyethylene, PVC, and etc. Each material, so each of these types of gloves are actually produced using different materials, and each material can protect well against certain chemicals, but poorly against others. So the choice of material and its thickness depends on its resistance to permeation. So that is why we need to always refer to our STS to really determine what type of glove from this list that we should wear. For the chemically resistant gloves, they are resistant to chemicals but may place the wearer at risk because um, of loss of dexterity, risk of ergonomic injury, or increased risk of being caught in rotating equipment if loose gloves are used. There's also no single glove material that could provide 100% protection from all chemicals. And a good all-purpose glove is the nitrile exam glove, which we typically use. Latex gloves have been the commonly used glove for many years, but it is not resistant to many of the most common solvents, unlike nitrile. Um, for using the glove, when using the glove, there are general rules regarding the chemical resistant glove use. Okay, for the nitrile exam gloves are the general glove of choice in wet bench labs. So before use, we have to check the glove, even the new ones, for physical damage such as tears or pinholes, and also for previous chemical damage. This is actually important when dealing with dangerous chemicals such as hydrofluoric acid. So we do not want the tears or pinholes goes unnoticeable and unchecked because we don't know because because it will risk the dangerous acid to seep into the holes of the glove and will come in contact with our skin, and it will cause burning injury. When working, it's advisable to wash the external surface of the glove frequently with water. Most chemically resistant gloves, especially lightweight disposables, are combustible. It keeps the hands well away from unprotected flames or other high temperature heat sources. Next, gloves for protection against heat or cold. Next is glove for protection against heat or cold. Thermal gloves. Next is gloves for protection against heat or cold. Thermal gloves for cryogenic applications are commercially available in a variety of lengths to be appropriate for the application. So there are several glove styles available for hot work processes, and most of them involving layers of leather, Kevlar, and insulating foam. So these just are the types of these are the type of the glove material that is used for protection against heat or cold. Then the thermally protective glove must be chosen based on appropriate length, level of protection required, and the level of dexterity required to accomplish the task at hand. So gloves made of asbestos, remember, gloves made of asbestos cloth are not allowed in the laboratories. Why? What is the reason asbestos cloth are not allowed? It is because asbestos is carcinogenic and it can cause contamination if come in contact with the lab equipment. So we do not want if there are residue of the asbestos cloth to come in contact with our skin after that and can cause the risk of cancer. And then cryogenic materials have temperatures roughly lower than negative 150 degrees C. This will instantly cause frostbite or burn of any exposed skin. Cryogenic materials are such as liquid oxygen, liquid nitrogen, and also liquid helium. So when dealing with this, there is a risk of frostbite or burn on our exposed skin. So that is why we have to wear a specialized glove that can protect us against heat or cold. This is a thicker material and a heavier material compared to nitrile and latex that we discussed earlier. Okay. There are three types of gloves shown here. There are latex, nitrile, and also neoprene. For the latex, it is biological and water-based samples. However, it has poor chemical protection and also poor material to handle organic solvents. And also for the nitrile, it is good and also general use of gloves, and it has some protection on organic solvents. However, it is not suitable for strong acid and base because it is too strong. It may tear the nitrile glove. Neoprene is good for strong acid and base and organic solvents overall, and it can be reused unlike latex and nitrile. So the material, as we can see, is more thick. It is also heavier and is also more durable. Next, we'll be discussing foot and head protection. For foot protection, we have to wear closed-toe shoes at all times in buildings where chemicals are stored or used. We cannot wear perforated shoes or shoes with holes in it or with gaps in it, sandals or closed sneakers in labs or where mechanical work is conducted. These shoes offer no barrier between you and chemical and physical hazards. So, and then chemical resistant overshoes or boots may be used to avoid possible exposure to corrosive materials, corrosive chemical or large quantities of solvents or water that might penetrate normal footwear, such as during spill cleanup. Because boots are made of really hard materials, so any risk of incident, any risk of any accident can be avoided. By avoiding it by preventing the chemical to penetrate our feet. And next, leather shoes tend to absorb chemicals and may have to be discarded if contaminated with a hazardous material. Next is head protection. Hard hats can protect employees from impact and penetration hazards as well as from electric shock and burn hazards. There are also bum caps. Bum caps is unlike hard hats. It does not offer protection against falling or flying objects. However, bum caps provide excellent protection against accidental impact with fixed objects such as exposed pipes or beams. They should be worn when working in areas with low overhead hazards. Next is lab safety equipment. The availability and use of safety equipment is essential to the practice of safe science. It should be present in well-marked, highly visible, and easily accessible locations in or near all labs that use hazardous chemicals. So these are the basic safety equipment. There are cities here, such as chemical fume hoods, safety showers, eye wash station, fire extinguishers, fire blankets, flammable liquid liquid storage cabinets, safety cans, refrigeration equipment, first aid kits, chemical spill kits, and portable safety sheets. If we are to observe, these are actually the basic equipment that is always in our lab set. That is in our lab setting. So these are the basic requirement to set up a lab. Well, under the basic safety equipment, we'll be discussing chemical fume hoods. What is a fume hood? It is a chemical and fire-resistant enclosure with a movable window, or we call it as such, front to allow the user access to the interior. And then it also captures, contains, and expels chemical emissions. In addition, chemical fume hoods with the sash down provide a protective barrier between lab personnel and chemicals or chemical processes. Unless the hood is designed to draw low volume, a properly functioning standard hood draws air from the lab at a velocity of 100 feet per minute with the sash half open or at the design operating height at the stopper. Okay, so we'll be discussing on fume hoods. This is actually a good example and also the bad example. The left one is the bad example of fume hood usage, and the right side is actually a good practice of fume hoods. So for the bad example, we can see that there are many excess chemicals stored here, and then there's supposed to be an exhaust slot, but due to the excess chemical bottles here, it is blocked. And then the containers also stored within just the 6 inches of face of hood, which is very, very near, and it can cause difficulty to close down the hood sash. And the hood sash is also set above 18 inches, which is quite far from the correct use of sash. This does not protect the chemicals from uh, evaporating to the surrounding. And then a good example of use of fume hoods, this is the exhaust lot that we cannot see earlier. And there should be minimum storage alongside the wall, and the sash is set at 18 or below, at 18 inches or below to ensure optimum protection. Next will be safety showers. It provides an effective means of initial treatment in the event of chemical contamination of the skin or clothing. Shower area must be readily accessible, clear of obstructions, and clearly labeled. It should also be tested annually to ensure that the proper flow is provided according to the standard. Other than shower, there's also eye wash station. It also must be easily accessible, unobstructed, and clearly labeled so that in the case of incident, the victim can immediately rush to the eye wash and also safety shower to wash the chemical that came in contact with the skin, for example. And the use of the hands must not be required to activate and maintain the water flow, because this could be that their injury may come in contact with the eyes. So the eyes, for example, so they could not like see their direction properly, or maybe the chemicals came in contact with the hands, so they could not use the hands properly. So that's why it should not be required to use hands to activate and maintain the water flow. So, and then eye washes also should be tested annually. So likewise, the safety shower to ensure that the proper flow is provided according to the standard. It is recommended that weekly eye wash testing be documented by the lab personnel to ensure that they are working properly. In the event of chemical contamination of the eyes or face, we have to immediately flush the eyes or face for 15 minutes and seek medical attention. This is the safety shower. So there is a trigger here. We just like pull, and then the the water will come down and shower our chemical spill. And this is the eye wash station. where we directly wash our eyes, flush down with water for 15 minutes. And then we'll be discussing about fire. Fire and explosions are major contributors to loss of life and property in labs. Most accurately, 67% of the fire were caused by electrical equipment, which is the wire and appliances. This make up 21% of the injuries, of the accident. And misuse of flammable liquids that make up to 20%, explosion 13%, gas 7%, and spontaneous ignition 6%. So the majority of the causes are electrical equipment. So the main is electrical equipment, and followed by misuse of flammable liquids. These two make the biggest percent of accidents caused by fire that is causing fire. This is a fire triangle. So these are the points to indicate the elements needed to produce fire. So a fire need these three. For a fire to be started, these are the three elements that are involved. That is heat, fuel, and oxygen. Without these elements, fire will not be started. So to extinguish fire, remove one of these elements. So either it's heat, fuel, or oxygen. Okay, there is the fire classes. These are the 5 fire classes. The first one is A in green color. It is used for ordinary combustibles such as wood, paper, cloth, etc. Next B, the red color. It is used for flammable liquids such as grease, oil, paint, solvents. The next is C, the blue color. It is to be used for live electrical equipment such as electrical panel, motor, wiring, etc. Next is D, the yellow one. It is used for combustible metal, such as magnesium, aluminium, etc. The last one is K, which is a black color. It is used for commercial cooking equipment, such as cooking oils, animal fats, and vegetable oils. Next, we'll be discussing fire extinguishers. These should be the appropriate type for the expected fire emergency. Extinguishers are classified according to a particular fire type. Class A is used for ordinary combustibles. Class B is used for flammable liquids and gases. Class C is to be used for live electrical equipment, and Class D is to be used for combustible metals and metal alloys. These are discussed earlier in the table. Most labs are equipped with combination class A, B, C fire extinguishers. Some also have the carbon dioxide class B and class C fire extinguishers for flammable liquids, gases, and electrical fires. A bucket of dry sand or marked as class D fire extinguisher, or commercial class D fire extinguisher must be present in labs where water reactive and combustible metal and metal alloys are used or stored. Are the fire extinguishers type. The material would be water, foam spray, carbon dioxide, ABC powder, and also white chemical. For the fire extinguishers of water material, it can be used to put out fire caused on wood, paper, and textile, but it cannot be used for flammable liquids, gaseous fire, cooking oils, and live electrical equipment. Foam spray can be used on wood, paper, and textile, and also the flammable liquids, but cannot be used for the 3 other categories. For carbon dioxide, it can be used for flammable liquids and live electrical equipment only. For the ABC powder, it can be used for most material, the wood, paper, and textile, the flammable liquids, gaseous fires, and also the live electrical equipment. As for the wet chemical, it can be used on wood, paper, and textile, and cooking oils, deep fat fires. So that's why ABC powder is the common one to be used in lab because it is more universal and more general to be used to put out different types of fires. Okay, this is the method to use fire extinguisher. Remember pass, which is pull, clean, squeeze, and sweep. For the pull part, we have to hold the fire extinguisher upright and pull the safety pin, and then start to back off by 8 to 10 feet and aim at the base of the fire. And then when we get our aim right, we can squeeze the lever and sweep side to side and sweep side to side to put out the fire. Next, we'll be discussing the fire blanket. It is a safety device designed to extinguish incipient starting fires. It consists of a sheet of fire retardant material which is placed over a fire in order to smother it. It is recommended in all labs that use flammable liquids. It also should be easily accessible and unobstructed. So it is easy to find, it is and quick to be used. If someone catches fire, the person should immediately drop to the floor and roll to help extinguish the fire, which is the stop, drop, and roll method. Then a fire blanket should be used next only as a last resort to help smother a body or clothing fire. Fire blankets can also be used to keep shock victims warm. Okay, this is a fire blanket. This is how it looks like. And this is the instruction of using it. It can be used for light duty and also on the coated surface to smother the flames. So next is the fire alarm. It is designed to alert us to an emergency so that we can take action to protect ourselves, staff, and the general public. So whatever the method of detection is, if the alarm is triggered, sounders have to warn the people in the building that they may be fire and also to instruct them to evacuate. And then the automatic fire alarm system are activated through fire detectors such as smoke or heat sensors. Manual fire alarms are activated with manual call points or pull stations. There's also a fire alarm control panel. It is a central hub of all detector signals to be wired to and provides a status indication to the users. Sounders emit a loud siren signal while flashes are for visual warnings and emit intermittent or rotating flashes, typically red or white. So these are the codes for fire alarm system. Okay, so these are the type of the detector. This is heat detector. This is how it looks like. This is the smoke detector, and this is the carbon monoxide detector. At the core of a fire alarm system are these detection devices. So there are a wide array of different types, such as heat detectors, smoke detectors, carbon monoxide detectors, multi-sensor detectors, and manual call points. Next, we'll be discussing on first aid kit. It is preferably packaged in hardcover cases to protect the contents. So this is how it is usually is. This is the first aid kit design that we typically see in work setting. It is always placed in a drawer or a cabinet. And the drawer or cabinet must be labeled first aid kit. It also must be regularly inspected and restocked as necessary. So commonly, we could see that there is a date of inspection attached as well, besides the first aid kit, to indicate that they have been inspected or will be inspected. Next will be the chemical spill kits. All labs must have this spill control equipment. Commercial spill kits can be purchased or just the necessary components assembled in the lab. So the most important keys to an effective spill kit are the location and the contents. It can be located strategically around work areas and fixed spots so they will be easily accessible. All lab must also know where the spill control equipment is kept and also must be instructed on how to use it. Everybody must have to know how to use it. And then the cleanup materials must be sufficient to contain the hazard type and volume of materials being used in the lab. The spill control equipment also, likewise, the first aid kit, it has to be regularly checked by the lab staff and restocked after use. Most of the kit contents are common items that may be found. That must be consolidated into a kit for emergency use. So it should contain absorbent material, appropriate personal protective equipment, or PPE, a container for spill residue, and a plastic dustpan and scoop. Labs that use mercury or mercury-filled thermometers and manometers should also have a mercury spill kit available. The following is a list of recommended items that should be contained in a chemical spill kit. However, it is important that spill kits be tailored to meet the specific spill control needs of each lab. Okay. For the absorbents, first one is the absorbents. For the universal, there are different types of absorbents. First one is the universal spill absorbent, which is a 1:1:1 ratio of mixture of floor dry or unscented kiloliter, sodium bicarbonate, and sand. This is actually an all-purpose absorbent. It is good for most chemical spills, including solvents, acids, and bases. However, for acids, it is not suitable for hydrofluoric acid. Second one is acid spill neutralizer. It is made from sodium bicarbonate, sodium carbonate, or calcium carbonate. Next is the alkaline neutralizer. It is made of sodium bisulfate, citric acid. So citric acid had to be existed to exist in a 2.5 kg bottle so that it is enough to neutralize the entire contents of almost any bottle of base. And then there is also solvents or organic liquid absorbent. It is made of inert absorbents such as vermiculite, clay, sand, floor dry, or oil dry. And then there is also bromine neutralizer. It is made of 5% solution of sodium thiosulfate and inert absorbent. Next is hydrofluoric acid. It is compatible, spill below, or neutralized with lime and transferred to a polyethylene container. Next is PPE. This is the one that we have discussed earlier. So it has to consist of goggles and face shield, heavy neoprene gloves, disposable lab coat and corrosive apron, plastic vinyl booties, dust mask or respirator, where all lab personnel must be properly fit tested before using a respirator, and various respirator filters should be available for specific hazards. The one that we discussed earlier with different color coding. The user must ensure that the correct filter is placed on the respirator to protect against the hazard present. Next will be the cleanup material. It consists of broom, plastic dustpan and scoop, and also plastic bags for contaminated PPE, and also one plastic bucket with lid for spill and absorbent residues, and hazmat bags to protect us from hazmat bags for chemical, biological, and or radiological cleanup. And then others are hydrofluoric acid antidote gel, which is calcium gluconate, or if hydrofluoric acid is used in the lab. Hydrofluoric acid compatible spill pillow is it's for if hydrofluoric acid is used in the lab. Aspirator bulb and mercury decontaminating powder for mercury spills. There's also dry sand or Class D fire extinguisher for spills involving alkali metals. And there's also oil dry, zorb oil, or dry sand for acid chlorides, and pH paper and tongs. Next, we'll be discussing storage cabinets. So flammable liquids in quantities exceeding a total of 10 gallons in a lab must be stored in flammable liquid storage cabinets or safety cans. Flammable storage cabinets shall be designed to meet NFPA guidelines or National Fire Protection Agency and is generally made from number 18 gauge sheet steel double wall construction of 1-inch exterior grade plywood. And then approved cabinet should be marked in conspicuous lettering such as that is flammable, keep fire away. So this is the sign that we usually see on the marked cabinets. Flammable cabinets are not required to be vented because cabinets are generally vented only if the flammable liquids generate noxious fumes. But if venting is desired, it shall meet the NFPA requirements. So there's also a different types of cabinet that is vented and also non-vented. Only flammable and combustible materials should be stored in flammable storage cabinets. So we need to segregate the types of chemicals to be stored in a proper cabinet. Next, we'll be discussing on the safety can. If a container, it is a container of not more than 5-gallon capacity. It has having a spring closed lid, spout cover. For next, we'll be discussing safety can. It is a container. Next, we will be discussing on safety can. It is a container of not more than 5-gallon capacity. It will have a spring closed lid, spout cover, and flame arrestor, and it's designed as it will safely relieve internal pressure. Safety cans must be compatible with the chemical that they are to contain. Safety cans with damaged parts such as corroded spark arrestor springs or insufficient springs must be taken out of service and replaced immediately. These the types of example of the storage cabinets that we usually see in the labs. This is marked as this is already marked cabinets and approved. So this will be the cabinet color identification. It is also categorized by color. So yellow for flammable liquids, red for combustible liquids, blue for corrosive liquids, white for toxic liquids, and green for pesticides and insecticides. Finally, we are reaching the summary part. Okay, for the summary, working safely with hazardous chemicals requires proper use of lab equipment. Maintenance and regular inspection of lab equipment are essential parts of this activity. So, and also many of these incidents that occur in the lab can be attributed to improper use or maintenance of laboratory equipment. And the most common equipment-related hazards in labs come from devices powered by electricity, devices for work with compressed gases, and devices for high or low pressures and temperatures. There are main points to remember from this session. So the point number 1 is to conduct a risk assessment for each lab protocol you perform to determine the type of hazards. Next, we'll have to select appropriate safety measures such as engineering controls, PPE, and work practices to eliminate or minimize risks. Next, we'll have to maintain a safe lab environment at all times. So do keep aware of any potential hazard surrounding us in the lab. And next, be prepared to handle lab emergencies swiftly and effectively. And never carry out experiments involving a fire risk at night or over the weekend unless a colleague is nearby, because we want to have people around us to help out if there's a fire risk. And then we have to know the location. You have to know the location of your nearest shower, fire extinguisher, fire alarm post station, telephone, and emergency exit routes from your own lab. Thank you. That's all from me.